In this video, we are going to discuss the chemistry of indigo, but first I want to bring their attention to this map because indigo originally was extracted from different plant sources, and there's a wide variety of plants that produce indigo, and some are better at it than others. And I love this map, which is from the Indigo Shade Map Project, which is responsible for sharing information about and helping to preserve different indigo dyeing traditions all around the world. And you'll see here there's multiple species of indigo that can be grown. Each color region corresponds to a different plant. And then all the different dots that are on the map correspond to famous artifacts that are dyed with indigo or current workshops that are working with indigo that are of note. Now, again, indigo originally and still comes from plants, but you don't just find a blue plant and then take the indigo out of it. It's a little bit more complicated. So plants that produce indigo make a precursor molecule called indican. When you break apart a leaf of an indigo plant, that indican is going to undergo hydrolysis, so it is going to lose glucose ring at the top, and it is going to make the precursor molecule indoxyl. And once that indoxyl is exposed to oxygen in the air, two indoxyls are going to come together, form a bond between the two 5-member rings, and then you're going to form the indigo molecule. The way that the chemistry of indigo dyeing works at the molecular level, though, is even more complex. So indigo itself is not soluble. We know it has to become soluble because it can, in fact, dye fabrics. You have to add in some kind of chemical called a reducing agent that can go in and donate 2 electrons to indigo and turn it into its reduced form called leucoindigo. And I've included pictures from when I did a very small scale indigo dye bath in the lab. And you can see here that the leucoindigo is yellow in color. And once the indigo is reduced, the dye bath turns from that blue, where you can kind of start to see a green a little bit on the top on the left, to yellow on the right-hand side. If we immerse a piece of fabric into a dye vat. So this is an indigo vat that I made in a bucket in my backyard, and I've dunked some wool yarn in there. When I first pull that yarn out of the dye bath on the left-hand side, you can see it's very slightly green, but almost yellow. And that's because that yarn is coated in leucoindigo. But as we go from left to right, and I've left the yarn exposed to air for longer, it's going to turn gradually more and more blue as the leucoindigo is oxidized back to indigo. So we have this process when we're dyeing of indigo where we need to chemically reduce the indigo so it will dissolve in solution and then coat our fibers, but then we need to oxidize it back. Now, when I showed you the mechanism earlier and we saw the structures of indigo and leucoindigo, I didn't throw any arrow pushing into there because the mechanism is not super straightforward. And in fact, there's actually 2 possible processes that happen. So regardless of your reducing agent, the reaction needs to happen under basic conditions, so at a really high pH. And it's the combination of having a base and a reducing agent that can make this reaction happen. Now, the first possible mechanism looks a lot like what I showed you previously, and that is there is a 2-electron transfer. And when this happens, the reducing agent comes in and it donates 2 electrons to the indigo molecule at one time, and you go straight from indigo to leucoindigo. However, for some reducing agents, and so this is actually the one that we see for sodium dithionite. You may also hear it referred to as the hydro or chemical vat. And this is the process that's most commonly used at large scale in industry because these chemical reducing agents are really, really strong reducing agents. And the mechanism for them is a little bit different than you might see for other reducing agents, especially ones that are more traditional and derived from nature. And that's actually a 2-step process where the reducing agent goes in and it donates 1 electron to that central carbon-carbon bond between the two halves of the indigo, and you end up with a radical on one of those central carbons, and then one of the oxygens on the other half of the indigo molecule is reduced to have a negative charge. And then there's a second step where another molecule of the reducing agent goes in and then actively adds another single electron to get the leuco-indigo form. And so both of these mechanisms are possible. However, the process can be different if you use a natural reducing agent, particularly by fermentation, which were some of the earliest indigo vat dyeing methods that we've seen.